Central Wyoming College, Todd Guenther, who's a professor of anthropology and history at Central Wyoming College, and he teaches anthropology, history, and museum studies courses there. He also directs the Western American Studies program, which has certificates in several research fields there. Professor Guenther received his bachelor's in anthropology from the University of Wyoming and his master's degree in American Studies from the university. His family lives on a ranch near Lander, and he is an archaeologist. He's been a former curator at South Pass City, is that right? And the Pioneer Museum in Lander. And in our discussions last night, every time we talk about someplace in Wyoming, you go, oh, I worked there. I was doing some archaeology, I worked there. And he has, in fact, worked all over the state. He's the author, an award-winning author of articles about Wyoming and regional history and prehistory. For those of us who are faculty members, we really like it when we see our colleagues, like Professor Guenther, who has been voted Instructor of the Year by both students and faculty at Central Wyoming, and his research publications investigating race, gender, and westward expansion have received awards from several Western states and organizations. And of course, this morning we have the privilege of experiencing Professor Guenther's teaching excellence and his expertise through his presentation entitled Living the High Life, a 12,000-year love story of humans and ice near the Dinwoody Glacier. Professor Guenther.
Thank you, Maggie. What you're looking at in this image is a Shoshone water spirit. Dinwoody, over by Du Bois, the east side of the Wind River Mountains, has been renowned among archaeologists and other people for over a century for this style of rock art that's common in that area, first identified in that area. And it's been renowned among native peoples for thousands of years as the place where the water comes from. You follow the river up to the creek, you follow the creek up to the glacier, and that's the source of water. It's been a sacred place to people for a long, long time. And this particular petroglyph is about 2,000 years old. And what I want to start with then is the relationship between the prehistory of that area and my students. About 20 to 30% of my archaeology students are native, mostly Arapahoes and Shoshones from the Wind River Reservation, but also Navajo, Chippewa, Lakota, Cheyenne, all kinds of kids and young adults from many of the western states. And a lot of them refer back to, in their minds, these early words from President Monroe when he first started this concept of placing Indians on reservation areas, that as long as the water flows and the grass grows and blah, 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 you will be protected. And what these students are looking at and reading in the newspapers and watching on TV is that the glaciers are disappearing. The glaciers where their ancestors have hunted for thousands and thousands of years are going away, will probably be gone in my lifetime, completely gone in my lifetime. And their question to me is, when the water stops flowing, then what happens to us? What happens to the Wind River Reservation, to our home, to my family? And so that's part of what we're dealing with here. I would probably have more native students in the archaeology program, except we also have cultural issues that we deal with. Some of them take classes, then say they want to come out on the field school, go home and discuss this with their families, and their elders in their families tell them, no, you can't do that. Not because they hate anthropologists so much, but because they are afraid that those kids will be out on these sites or graves or burials or whatever and bring evil spirits back home with them. So the whole thing that we're talking about here today is kind of walking between cultures and walking between time periods, the past, the present, the future. And we're going to start with the science of all of this. Students on Fire and Interdisciplinary Climate Change Expedition. At CWC, we have the entire Wind River Range as our backyard. We play up there, and now we're trying to get the students really fired up, take them up there to work and actually do research. It's a little bit different kind of a program than what's standard from most college campuses, where the students, at least my recollection of being an undergraduate, is you're slave labor for a professor. And what we're actually trying to do is teach the students how to do research, how to identify a project, find the money to fund the expedition, fund the research, then accomplish the research and write it up and present it. so that we're a teaching institution, but we also are conducting research and teaching them how to be the next generation of scientists. And so this has become quite an adventure for us. This expedition that we did last summer, where we took about 20 of those students you just saw up to the highest mountain, Gannett Peak, Dinwoody Glacier, the highest part of Wyoming, was an adventure for all of us, one of the highlights of my life. The whole concept is based on teaching the students mountaineering skills. If we can't get them through streams where the cold, rushing water is up to their armpits while they're carrying a 50-pound backpack, and get them up there and then back down safely, teach them how to camp in bear country, teach them how to rope up and rappel down the side of a glacier or across the crevasses. Well, I've got 3 of my bosses here to make sure that I bring my students home safely and alive. And last summer I had to swear with blood to 3 different mothers that I would bring their child home alive. And they didn't believe that I could do it. But so the mountaineering skills is where our outdoor education program comes into play. And we teach the students, in addition to all those academic skills, how do you survive in the wilderness? How do you take a group of people up into a place where people maybe don't belong and do research? And so that's the foundation for the glacial studies and the archaeological studies. We have to keep them alive before we can do anything else. And these are 2 of my colleagues. Jackie Clancher on the left is the genius that conceived this whole idea several years ago. Darren Wells is the outdoor education professor at CWC. And I need to start pacing because I can't stand still. But Jackie invited one of the world's best-known glaciologists to join us on this expedition. And notice a little map of North America and Greenland up above there. This guy actually laughed at her on the telephone and said, "You got to be kidding me. I can get on a plane and be on the ice in Greenland faster than I can get to Dinwoody, and I don't have to spend 3 days with a 70-pound backpack on to get there." So that's part of the reason that we have so little information, so little scientific knowledge about the glaciers and the winds. They're hard to get there. I mean, this is Jackson. We're in Lander, we're in Riverton, we're used to playing in the mountains. To us, it's no big deal. Oh, it's cold. Oh, it's snowy. But to people from other parts of the world, they have different attitudes about the remote wilderness areas than we do. And this is a classic example, and it's part of the reason that federal agencies like the Forest Service, the Bureau of Land Management, the conservation districts are asking our little sophomores and freshmen for their research data, because that's the only research data we have on the glaciers coming out of the winds. University of North Dakota sends crews up there occasionally, but when we're talking about doing these multi-year cutting-edge research projects, people want the information that we're generating. Some of the students, most of the students on that expedition are actually hard science. They're biology, chemistry, physics, geology, those kind of disciplines. And what these kids are studying here, or young adults I should say, sorry. What these students are studying here is the water quantity and the water quality coming out of the glacier. How much water does come down? They measure the flow, they measure the mineral content, what is in the water, what's the sedimentation, the turbidity. They're looking at all kinds of different aspects that affects drinking water downstream, it affects irrigation, it affects all kinds of issues. This girl, Lulu, is taking water samples to study how much sewage, raw sewage, is in the water coming out of the glacier. One research question that she had is every year there are hundreds of people from all over the world who climb up over the Dinwoody Glacier to access Gannett Peak and climb it. It's the highest peak in Wyoming, and so it's a target for lots of climbers, and they all defecate all over the top of our beautiful, pristine, formerly white glacier. And so what she's doing here is taking water samples, and then we had at 11,500 feet last summer what is probably the highest biology lab in the country. It looks a lot like a tent because it was a tent, but we also had incubators in there, and the little purple samples, she's trying to incubate E. coli, and what we found out up there is that the elevation is so high and the UV light is so strong that it sterilizes and purifies the water that's coming off the glacier. So when that water comes down off of the glacier, regardless of how many people from France or Switzerland did whatever it is they do up there, our water is clean when it originates at the head of the stream. We also, in terms of teaching the students how to rope up and rappel, this is the very top of the Dinwoody Glacier. This is the absolute high end, and we've got students sliding down the side with ropes and taking snow samples, digging back into the ice a little bit to get black carbon samples, because we know that you can't see it,
black carbon is microscopic, but you can identify where it comes from. Does it come from bus engines in Tokyo or Beijing? Does it come from Four Corners area power plants? Does it come from all the automobiles in Los Angeles? Where does the black carbon come from that's in the atmosphere, that lands on the ice and is exacerbating the melt rate of the ice in our Wind River glaciers? And so we're still working on the results from that. We're still doing the chemistry on that to try and come up with that and find out where all that source is. We've got other students that use global positioning systems and geospatial information science and technology to map the perimeter of the glacier and within a centimeter or two, the elevation of the upper surface of the glacier. And this is where it really starts getting scary, because between August of 2014 and August of 2015, the Dinwoody Glacier and all of the glaciers in the winds lost 2 meters. That's almost 6.5 feet of surface ice off the entire upper surface of the glacier. And when people talk, you know, you've been reading in the newspapers now for 10 or 15 years how the glaciers are melting and they'll be gone in 100 years and blah, blah, blah. I will tell you that my irrigation ditch, south of Lander, which dates to the 1880s, went dry the 1st of August, 2 weeks before we went up there. And this whole idea of running out of water in Wyoming at the head of the Colorado, the head of the Wind, the head of the Snake, is no longer just some kind of academic idea, some projection for the future. It's history. It's past. It's already in play. We in south of Lander couldn't grow the rest of our alfalfa. We couldn't feed our own cows because we're running out of water already now. So it's not just some arcane academic projection any longer. And we've got sophomores at CWC are generating the data that documents all of this. And it's a very disturbing situation, both for my white students and my native students. Because when I tell them that they're going to be out of water before I'm dead, they think that will be tomorrow. And so they're a little worried. Related to that, this is a team, we had a $50,000 ground penetrating radar device up there that these guys dragged, and it takes so many people to do that because everybody's got to have crampons on and rope up because you have to keep that thing from sliding down. You're on a 45-degree slope, there's water running down the ice, it's very slippery, and if they lost the GPR, the people at UW who act like our friends right now and actually own that thing would not be happy with CWC any longer. But so we rope up and try and protect the GPR, the ground penetrating radar, and drag that back and forth across the ice. And there are large areas of the Dinwoody Glacier where the ice is only 20 meters thick. So if it continues to melt at the rate of 2 meters per year, you can do the math. It's second grade level math. We're in trouble. So that's part of what's going on. Here's a photo 1935 of Dinwoody where the ice went hundreds of meters on down the canyon behind where this photo was taken. And then here's one we took last summer, 2015. We're running out of ice. We are running out of water. And the reason I went on this trip, as one of my former students told me, I'm not a real scientist. Archaeology is a soft science, not a real science. And that's the kind of stuff you have to put up with in college. I'm also going to perform his wedding ceremony this summer, so I'm kind of looking forward to that. He thinks he can say anything to me. But two of my students, these two, in fact, Chelsea Cheney here is from Jackson. Two of my students went up on the ice expedition in 2014. Two of the smartest, most dedicated, brightest archaeology students I've ever had. And what they found from the trailhead just outside of Du Bois all the way up to the foot of the glacier was archaeology. There are artifacts for 25 miles all the way up. And they got pretty excited about that. They came back down, and that's where the torture part began, because they started telling us, the rest of us about what they found. Here's a stone tool. It's been sharpened along that upper edge. You could butcher an entire bison with this thing, and people probably did based on where we found it. Part of what I try and teach these guys is stuff that I did not learn until after I got out of graduate school and had to do it myself. How do you field an expedition? So I told them, if you guys want to go back up to the ice, back up on the mountain next summer, 2015, you're going to have to help me do all the paperwork, plan the whole thing, figure out the logistics. If you have 8 people, how much food, how much toilet paper, how much everything do you have to put in your backpack? And then we've got to deal with the Forest Service to get research permits to go into the wilderness area. There are about 4 or 5 of those that are given out. So we're lucky to get that. Fundraising, where are we going to come up with $30,000 to pay for the whole thing? And then all this hard behind-the-scenes drudgery, where they also had to start writing up Smithsonian site forms for what they found in 2014 so that we could integrate our whole project into the Wyoming State and the National Smithsonian System for doing archaeology. Since 1906, when Teddy Roosevelt passed the first Antiquities Act, we have become one of the most highly regulated academic disciplines. I would rank it right up there with the nuclear energy industry. We have so many laws that we have to abide by, and they're all enforced. So these guys need to understand that and all of these skills before they leave my little flock anyway and go out into the world on their own. So we had funding. We wrote grants. NASA wants to know about the ice and the climate. And EPSCoR and INBRE and Wyoming Public TV, Central Wyoming College puts money into this. The Cultural Trust Fund, UW, Archeological Society. I probably spend 200 or 300 hours a year just writing grants to fund the field school and these student research projects. And when that was all done, it was time to play, or so they thought. I don't know what all the other science, the hard science students did, but I take my archaeology students and we leave in late May and live in tent camps the rest of the summer, working, as Maggie said, all over the state. 2 weeks here, a month in the mountains there, a week in this desert, and back and forth living like gypsies with all the trucks and trailers and equipment and everything else, and hiking up and down the steep hills with heavy backpacks. If we're going to be gone all day and it's 100 degrees, I want them to have a couple gallons of water with them. So there's 16 pounds of water in their back right there when they start in the morning. And they have to learn how to do all these things, take care of themselves, and do the archaeology, and prove themselves out here in the field school before I will take them up onto the glacier, that they will be pleasant company in the field, that they know how to do the archaeology, that they're in good enough physical condition to make the trip, and on and on and on. So that's what we did all summer. And then by the middle of August, we thought we were in shape and thought we knew everything, and so away we went. Up into the Fitzpatrick Wilderness, drove the trucks up to Dubois, jumped out, and started hiking up the trail. And this is 1 hour from the trailhead. Everyone is still happy because no one has even broken a sweat yet. And this is a little non sequitur. I'm going to break the flow here for a minute because you need to understand about me that I was a fish out of water on that trip. I come from a background where if God had meant you to carry all that stuff, she would have given you 4 legs. A horse is supposed to carry everything. I spent 17 years outfitting trips like this for the National Geographic, for the U.S. Department of Education, and for other colleges from Rhode Island to Colorado, where we took teachers out on the trail for 10 days at a time and taught them about Western American history and how to teach it better. And there are a couple people in the audience here who've been on these trips and know how these people suffered. Choking dust, punishing wind, freezing nights, blah. This was good practice for all kinds of things. In addition to the physical aspect or the mental change of carrying all of my stuff on my own back, most of my research is focused on westward expansion, race and gender issues in the great pageant of the development of the American West. And so this ice expedition was a bit of a learning experience for me too. These are the archaeology students that made that trip up there. They are smart, they are tough, they are innovative, and I would take any of these people anywhere at any time and recommend all of you hire them and double their pay when you do. And in reference to the toughness, this is day 2 hiking up to the glacier. And if you look back behind them, it's about 800 feet down to the bottom of that canyon, and then we had to pack 800 feet back up the other side, and 800 feet down into the next canyon, and 800 feet back up. We were up there for 11 days. I lost 15 pounds. That's after being out in the field carrying a backpack all summer long and thinking I was in good shape. This kind of an expedition is a physical challenge, it's a mental challenge, and once you're up there, you cannot get voted off the island. I told them that I am the oldest guy on this trip, and I will be the weak link that they have to keep up no matter what, because if one person for any reason fails to keep up, the whole expedition is shut down. We can't just leave them there as bear food while we go up and do the science. So it's really important that they're all in better shape than I am. And these are the real science students. These are the physicists and the chemists and the geologists and everything. And they're good little lambs. They stay on the trail and they're quiet so they don't disturb the wildlife. The archaeologists are like when you go on a family picnic with your dog, and it goes and sniffs every rock and looks under every bush and wanders around. We have to do that, or we don't find the stuff that people left when they camped there 5,000 years ago. So while everybody else is walking up the trail, we're sweeping back and forth across from side to side the entire valley. So the other crew will walk 10 miles a day from one camp to the next camp, and we're doing 30, just like your dog. And so that's part of the reason I lost that's my excuse for the reason I lost all that weight. And these guys love it. They're so motivated that they are going to take over the whole discipline when they get out of graduate school. But what they found is archaeology, again, like the previous year, everywhere. But this time we were prepared. We had the technology and the papers and the forms and the cameras to record everything. Our operating assumption when we went up there, our scientific model, was that, well, as everybody knows, the sheep-eater Indians were related to the Shoshones, and they would hike up into the mountains in the springtime and come back down in the fall. It's in this book, it's in other books. Thousands of years this went on before they had horses, just had dogs to carry their stuff. In recent years, some of my colleagues from back in the days when my hair was red and he had hair, like Rich Adams, some of you know him, you've heard him speak up here, I have been finding like the high-rise village site, which is very near where we were going up to Du Bois. Matt Stern from Jackson here has been finding evidence of humans and bison at 12,000 feet in the Tetons. Marcia Peterson from the State Archaeologist's Office been working on Table Mountain up here, and also in the Gros-Ventres, and finding bison bones coming out of the ice patches at 11,000 feet. So what those people have been documenting for several years now, about the last 10 years since people got into this high elevation archaeology, is that there were more people up high than we realized. And what we found this summer is that the picture was even more complicated than we realized ourselves. And right off the bat, we began finding what the girls are recording here. All those wire flags mark the locations of artifacts on the ground. And so they're using GPSs and cameras and notes and all kinds of, making sketch maps of the features and the sites and everything. This is a remnant or a foundation of a fire pit and what's left of an old wickiup, the pole structure shaped like a teepee that people lived in up in the mountains. They didn't like carrying their teepees up there when they went in the summertime. A bison skin teepee, the leather covering weighs anywhere from 400 to 800 pounds. It's a load. So they're not going to burn all those extra calories carrying that up here. What we found when we worked up there is just to work at that elevation and the kind of physical labor we were doing, people burn anywhere from 4,000 to 6,000 or 7,000 calories a day. So we're really just putting it away 3 times a day and snacking in between meals. And those prehistoric people would have had the same biological needs. They had to be eating all the time. And all of their technology, they didn't have dehydrated food. They didn't have lightweight camping equipment. Everything they had was leather, wood, or stone. The archaeology really began to get interesting, though, and left our predicted models on this site. And where we are here in this circled area is a real interesting site. Right at the toe, this is 50 feet high. That's a 5-story high wall of rock. That's the terminal moraine of the Dinwoody Glacier at the end of the Little Ice Age. As the glacier came back down in the medieval times, it pushed this wall of rock ahead of it and then has been retreating back upwards from there. So this site that we're looking at in the circle here is right below that terminal moraine. And this is where we first started to realize that people were trying to get as close to the ice as they possibly could. As that ice retreated from the left to the right over the last couple thousand years, what we have is at this end, at the north end of this site, we've got 3,000-year-old deposits. Here in the middle, 2,000-year-old deposits. At that end, right under the arrow where those little tiny specks are my kids, my students. And that's for scale, because when you're looking at this picture, it's mind-boggling, the scale of the geology and the terrain up there. And you look at that and you understand, yes, those are boulders, but those boulders are bigger than this building, some of them. And where those kids are working right now, the archaeological deposits there are about 1,000 years old. So as the glacier is melting back up that way, people are just continuing to camp right next to the source of the water. That holy place, like that water witch, that petroglyph, they're coming to the origin of the Dinwoody. They're coming as high into the mountains as they can. And we have a lot of stereotypes in white society, both academics And in popular public society, the Indians were lazy, the Indians didn't like the cold, the Indians are dumb, blah, blah, blah. It's in all the publications for the last 120 years. But what we're finding up here is that they were going as high as they could to the coldest, nastiest, most hostile part of Wyoming that they could find, and apparently they enjoyed it. This is a particular site, though. You can see that terminal moraine down there in the bottom of the canyon, so we're about a quarter mile below that. This is the one where things really started to change. Because 9,500 years ago, somebody made a spear point out of obsidian from Yellowstone and dropped it right under this boulder, where that girl is about to pick it up when this photo was taken. And it appears that about 9,500 years ago, right here, people took shelter behind these boulders and camped there. This is the end of the Pleistocene. There are still mammoth wandering around, Bison antiquus, twice the size of a modern buffalo that people were hunting. And these were the people that did it. And this is where they camped. And at the time, it doesn't quite show up with this projector, but there's another girl standing right up here in the middle of that photo. That's where the wall of ice was, the end of the glacier, the terminus of the glacier 10,000 years ago. On the other side of the creek from this site, and about 100 meters farther north, we found another projectile point, which is even older, 11,500 years. That's the brown one. Now, those don't look like much to me. I mean, I still would like to be Indiana Jones and find the cool golden skull, on the Ark of the Covenant and all that stuff. But typically, what archaeologists find is the broken junk and crap that people threw away because it was broken junk. So we've got these two spear points. The one on the right there is particularly interesting. It's a Goshen point, 11,500 years old. It's probably the second oldest culture behind Clovis in Wyoming. Some of the very first people that came into North America made this. And these are people who used those points, glued them onto the end of a stick, and went up to an animal the size of a truck and speared it. And we know that they didn't all get stomped on by the angry animal afterwards, because we have bones in Wyoming with butcher marks, with the marks of stone knives on the bones where they peeled the meat off and then ate it. And we've got mammoth kills with spear points in between the bones and so on. One problem with this is the side of a mammoth, the skin, like on an elephant, is too thick to actually get a spear through, so there's a little artistic license going on here. But essentially, you still had a thrusting spear or maybe a little dart atlatl that you could throw, but you still had to get in close. So those points were made by people who came down from Siberia, across the Bering Land Bridge, down through Canada, along the coast or along the Rockies, the Snowfree Corridor. And the common wisdom is they kept going south to get down someplace warm, like Galveston or Texas City, or where the air is so beautiful, right? Or down to Mexico and, down to Belize on the beach and things. But what we're finding here in Wyoming is that there was a small number of those people who, instead of going towards the sun, came right back up to the highest, coldest, toughest, nastiest place they could find, year after year after year for thousands of years. There's something about that Dinwoody area, that glacier up there, that they were in love with. And what we've been finding is putting together the geological information about the recession of the glacier from the top, coming up the canyon towards the south. The red line is where the glaciers were about 10,000 years ago. The purple line, 6,000 years ago. And then the blue line here is that big wall of rock that I showed you, the little Ice Age moraine. And the black circle up there, the black oblong, is that site with the two paleo components from 9,500 to 11,005. And people are moving up with the ice, again, up till the very end, the little black circle at the bottom there between the two blue lines, where 3,000, 2,000, 1,000 years, they continued to stay as close as they could get to that ice. Why? I don't know. We're still working on that. We will go up and do some test excavations up there this coming summer. This is a site that's really turning things upside down, though. And rule number one in archaeology is that you always find the coolest thing on the last day of the project. And that way, my students tell me I'm very old and I need to learn patience before I die tomorrow. It doesn't work. So we found this as we had our backpacks on and we're coming back down to the trucks at the end of the project. And what you're looking at here are three examples of stones. Like this one is set up in the ground like a gravestone. Here are some that are piled on top of a bedrock outcrop. Here's one where there's some more smaller rocks piled up on top of a boulder. It's a mile-long line of stacked stone cairns, like this, little piles of stone that extend for a mile across a mountainside, a tundra mountainside. And when we followed that from one end to another, we figured out it was a buffalo jump at 11,000 feet. Most buffalo jumps are in places like Nebraska and South Dakota, eastern Wyoming. They're between 3,000 and 5,000 feet above sea level. The next highest jump in Wyoming, as far as we can tell, is also the next highest jump in North America, is about 8,000 feet. This one is at 11. So it's the highest bison jump in North America, and I've got people telling me, well, there were no buffalo up that high. But like we already talked about, Matt Stern from Jackson here, Rich Adams, other people working around Wyoming, they're finding bison bones coming out of the ice at 11,000 feet. We know there were buffalo here at this height. We also have historic accounts written by some of the early fur traders, Jim Bridger and the rest, that talk about mountain buffalo being up high. So we don't have a problem with that. And what we're looking at on this site is a place where they had about a 2,000 acre gathering area to haze small groups of animals into a herd and then ease them along this line of stones, which had people hiding behind them and in between them, and then run them over a cliff and kill them, where you can kill many, many at a time. So where the one girl is standing on the crest of that ridge, you can see one of those piles of stone right beside her, and that whole line of stone runs along that side of the ridge, and they move the bison from the north on the right-hand side along the top of this ridge to the left, to the south. And on the uphill side here, what you're looking at is a hunting blind, where people dug down into the ground and scooped that out a little bit and piled up stones in a circle or a semicircle, and we've got several of those along here, so that as the bison were moving along from right to left, as they passed, people could stand up from behind those stones right over there, stand up behind these blinds, wave their blankets, start to yell, jump up and down, and get those animals to stampede, because buffalo don't naturally jump over cliffs. It's not something, I mean, it goes against their survival instincts, so you have to stampede them. And even though the first ones will come up to the cliff and see it and try and stop, put the brakes on, the others coming behind will push them over to their death. And you might, out of a herd of 100, you might kill 20, you might kill 50, doesn't matter. You still have 20 or 50, even if some of them get away, you have plenty to eat. And we also found, as part of that drive line, what appears to be what they call a shaman structure or a shaman hut. It's a little dugout place in the ground where people dug down in there and then stacked rocks up around it. It's just big enough for one person to sit down cross-legged and sing or pray to the bison that they will come sacrifice themselves so that I can feed my kids this winter. And that's a common component, whether it's an antelope drive line or a sheep trap or a buffalo jump in other parts of the country. The only thing odd about this is the elevation, and that's very odd. So this is the last thing that those buffalo saw before they went over the cliff. This is the view from the precipice of the little escarpment. It's about 15 feet from where the photographer's standing down onto that little flat area, and where those flags are represent concentrations of artifacts. We only had 100 flags with us. There are about 10,000 pieces of lithic debitage in that little area right there, broken stone tools, flakes for where they sharpened a stone knife so that they could keep butchering. I think this site was probably used over and over and over for many generations. At least several centuries, maybe several thousand years it's been used and reused. And what we'll be doing up there this summer is conducting some excavations to see if there's buried evidence of earlier use or more intact deposits than what we found. Now you're going to look at this. This is a side view of that escarpment and think that's no buffalo jump. Guenther is a liar. You don't have to have a vertical cliff face to kill buffalo. All you need is something like this, or even just a steep slope where they come over the edge and break their legs between the boulders, break their neck when they fall down. And then you can come finish them off with a club, you can finish them off with a bow and arrow or a spear or whatever. You don't want them, you don't want something that looks like this, where you're chasing them off a 200-foot cliff. You've all seen what a deer looks like on the highway after it gets hit by a semi. That's what your buffalo would just splat at the bottom. You don't want to eat the meat. It's full of bone splinters and jellied and everything. This is it's a famous painting up in the Buffalo Bill Museum in Cody, but it's not a real buffalo jump. So this is another real buffalo jump that my students are recording. This is on the Wiggins Fork outside of Du Bois. It's about 10 miles away from the Dinwoody jump and thousands of feet lower. And they ran the buffalo over the lip of this ridge at the upper left and then tumbled them down that slope. And that was enough to either stun them or disorient them or maybe break a leg or break a neck. Again, you don't need a cliff. And you're looking at this thinking, at least I hope you are, you're all highly educated and questioning minds and everything, and still like my students thinking, he's making this crap up. He's not telling us. Their favorite quote is one that my daughter originated: if his lips are moving, he's lying. So I shouldn't tell you this, but the cat's out of the bag now. But we know this was a buffalo jump because we have evidence in the creek bank right below it. At least 5 episodes, 5 different bone layers in the stratigraphy of that creek bank. You can see the big skull coming out right here. And the girl up there that's handing me that leg bone is Chippewa from up in northern Montana. And her great-grandparents were still chasing buffalo, bison over cliffs up there 150 years ago. She's looking at this thinking, this is my people. And so we know that you don't have to have a cliff to have a buffalo jump. Some people have, I got 2 emails yesterday from people who heard about this talk, archaeologists, who said there is no buffalo jump up there. I've been there 40 years. There's nothing up there. There's no on and on and on. But we have all the components of a jump. I'm not worried about that. We've had other people who say, well, maybe it was a sheep jump. Who laughed? That was my reaction too. You can't have a sheep jump. They live on cliffs to escape predators. You can't chase mountain sheep over a cliff to their doom if you're trying to fill your larder. If you're going to have a sheep trap, you have to have a log structure like this old 200-year-old, what remains of this log corral, very carefully designed and built so that sheep can't get out of it. But our little escarpment there of boulders at 11,000 feet would not kill sheep, but it will kill bison. So what we have here is the map of the whole site that shows the individual locations of each of those piles of stone, a mile long, and then this little circle down here is the butchering area right at the foot of the cliff or the escarpment where the butchering was conducted. And the photograph up there at the top shows the arrows, shows the travel plans for those bison as they were hurried along the ridge and then over that last little rise to their death. So that's what we're looking at in terms of this buffalo jump as an aberration. If there's only one, it's not that important. It's just a freak. If we can find more of these up high, then it shows a broad cultural trend, more of an adaptive pattern than just one instance. Even though this was used, we think, for over and over for many generations. What really becomes interesting about this buffalo jump, though, is what it means to another one of the white stereotypes, is that if there were hunters, if there were Indians going up into the mountains, it was probably just groups of young men who would go up and be obnoxious young teenagers, just like all teenagers are. But if there's a bison jump, you have to have every old man, every grandma, all the aunts and uncles, all the kids, and everybody in the village has to be there to line the drive lines and keep those buffalo moving, to jump up from behind the cairns and wave their blankets and shout. It's a communal hunting effort. It's not just something where a few young men would do. You have to have not only the whole family, not only the whole extended family or the whole band, you have to have the whole tribe up there. It's going to take 50 or 100 people to pull an operation like this off. And so that meant that, unlike some of the stereotypes, this was a hunting event that involved women and children, not just the usual story about the manly men up there. And that got us wondering. This is the view from the jump down over the valley floor below the jump site. And that got us wondering, like the girl sitting there pondering the realities of life, where did those people live? And so we did, and remember, we were here for a day and a half. It was at the end of the expedition. We didn't have time to do detailed recording yet, but we sent some of them on a quick sweep of that entire timberline across there, about a mile and a half, and the entire thing is covered with campsites. We've got remains of wickiup lodges, those pole structures. We've got teepee rings where people actually had teepees up there. We've got open camps. We've got fireplaces where people were cooking. We've got 4,000 years of different types of projectile points. There were thousands of people over thousands of years that lived right along that tree line, and those are probably the ones who used this jump over and over and over. So we've got something interesting here that changes the way we have these assumptions about who lived in the high country and what they did and how often they did it. But then it really starts raising some more questions. Family of Plains Indians, got their lodge, a couple of women, little girl, and what you see hanging on the poles up here in the upper left is drying buffalo meat. That's how they made jerky. Cut it real thin when you're butchering the animal and hang it on the poles in the sun to dry. But what are you going to do if you have 50 dead buffalo? you're going to wind up in a matter of days with thousands of pounds, literally tons of jerky. You're up there in the mountains at 11,000 feet, and our white supposition is, oh man, they grabbed all that stuff and headed down to the valley before it started to snow, just like we would do. We, as human beings, perceive the world through our own eyes. But what we need to do to start understanding these newly recognized high country prehistoric adaptations is look at the world through their eyes. Remember how many calories it takes just to live and work up there? If you have thousands of pounds of bison jerky, and you have thousands of pounds of pine nuts that you put up during the summer, and thousands of pounds of sago lilies and bitterroot and all kinds of other plant foods, how long would it take you in those pre-horse days to put that 40 pounds per dog back and forth up and down the mountain? You'd spend the next 14 months carrying all that food down to the valley by Du Bois or Lander or Casper or wherever. So we began to ask the question with these students, could prehistoric people winter in the high country? Nobody in their right mind would work that hard to carry all that food down. I think they would just stay up there regardless of the snow. But we needed more data for that. And unfortunately, I was not allowed to take anybody else's kids up into the mountains in the wilderness area in wintertime. It's something with the moms again. They think, you know, you cannot kill my son or daughter. Luckily, my son just got out of the Army. First Lieutenant, 82nd Airborne. He knows how to survive. He can outrun me if the bears attack or whatever happens. So we geared up in the middle of January, 2 months ago, to snowshoe up into the wilderness up to 11,000 feet and see what that area around the jump and that camp area looks like in the middle of winter. And as you can see, there's almost no snow. The snow was an inch or two deep. Yes, this is January when this was taken, so it's a low snow month. Yeah, it's a drought year. But what we found, and you can document this based on the vegetation patterns, what grows where as well, is that the entire area around that jump site, about 4 or 5 square miles, blows clear of snow because of the slope and the aspect of those slopes, those mountainsides, just blows clear of snow because of the prevailing winds. So we never even put our snowshoes on. We didn't need them. We walked the whole way in there in our boots, and it was really interesting because as we walked, there are all kinds of wild animals up there that winter up high too. If they could winter up high, then there's no reason human beings couldn't winter high. So we saw several herds of sheep. Again, notice there's no snow on the ground. The southern slopes are completely devoid of snow, and even if you got a 2 or 3 foot snowfall, these slopes would blow clear and the solar gain would melt the snow and the slopes will be clear and grazable again in a matter of days. We saw moose. People in the Forest Service told us no moose up there, but we saw them. This one was at 10,500 feet, almost up to the jump site. When we got right up to the gathering area where we postulate that people put those bison herds together to chase them over the cliff, we found wolf tracks. And that was intriguing. That supported some of the guesses that we'd made earlier. In November, I took about 20 of the students up to Yellowstone. We worked with the Wolf Project people in the Park Service and the Yellowstone Association, and we studied wolves interacting with bison and elk in Yellowstone in the backcountry for 3 days up there. And so when we saw these tracks, when my son and I saw these tracks there at Dinwoody, we were able to almost visualize what had happened. And so we cut their tracks. We cut the wolf trail shortly before we found a wolf kill, where they devoured in 2 days, devoured this elk. They even peeled the hide off the skull, ate everything but the skull in the bottom, the pelvis over on the far right, and the vertebral column here, ate the ribs off, gnawed that thing to pieces. And this is where we cut their trail, and this is where they did exactly what we expected prehistoric humans would have done. We're looking south here, and our guess was that prehistoric humans would have started from the north and worked all those buffalo towards that saddle, right where the arrows are pointing, and on the other side of that saddle is the jump, and then jumped those buffalo over the cliff. And what the wolves did is they came in from the left to the right on this image, and we cut their trail here, and they fanned out immediately like they knew what they were doing. They had a pre-planned this hunt, fanned out across this valley, and worked parallel simultaneously with each other and drove those elk up exactly like we postulated that people would have done with bison. And I was discussing this with an old Shoshone elder who would not appreciate being called an elder because he's my age. But we visited about this a little bit, and he looked at me. We've known each other for years, and he looked at me like, you white guys are so stupid. Of course that's what happened. Of course that's how the people did it. Grandfather sent the wolves for us to watch so that we could learn how to hunt that high country. And to him, there was no surprise at all that wolves and people would have hunted that ground the exact same way because people are the apex predator. We are higher on that food chain than wolves are. And this is the view from the saddle looking down towards that line in the timber where all the camps were. And even out there on the flats, the snow is only 3 inches deep. So, and in the timber there's plenty of firewood. And in the timber there are springs that were flowing in middle of January. And it was cold, it was below zero. There are springs that were flowing open water up there. So if you had 5 or 10 tons of bison meat and thousands of pounds of pine nuts and other plant foods, you could winter up here and it wouldn't even be hard to do. You just stay in your lodge, make love to your wife or your husband or whatever, and you've got more food, fuel, and water than you need. There's no reason to expend all those thousands of calories to pack all that stuff down below. So one of the things that we'll be looking for, part of our research model for next summer when we go up here and start to excavate, is can we find proof that people were up there in the wintertime? We've got plenty of evidence now how they got their food, plenty of evidence that it would be possible to winter at elevation, even though we don't want to with modern technology, unless you're at Togedy and you get a truck of propane every couple days and a truck of gasoline and a truck of groceries. Those people were self-contained. They didn't need those resupplies, but they could have wintered up here very easily. And, bison spend the winter in Yellowstone. Nobody has a problem with that. I think they could have spent the winter up on Dinwoody too. So people did winter up there. Men, women, children, grandparents, the babies, everybody in these teepee camps and wickiups along the edge of the timber. Before we got back down out of the mountains, I started getting emails. It's the beauty of modern society. I used to be able to go up there and Mark couldn't get a hold of me. Now I have my phone and I get emails that the business office wants something signed or I need to do something for Mark or Brad needs it, whatever. Whoop, broke the phone. Not to Brad, no, it was someone farther down the food chain, must have been Kenna. We started getting emails from researchers in Norway doing the same types of projects that we're doing, only it's in the Arctic. In the highest mountains of Norway, they're using the same techniques, the same field methodology, they're finding the same kind of sites, drive lines. And this is really cool to me because the Jotunheim, that's the giant's home. Jotunheim, giant's home. That's where Odin had to go to kill the giants so that he could become the supreme being. That's where my dad's family comes from, high up in the mountains of Norway. We were so mean and rotten they wouldn't let us in the boat to go to England with the rest of the Vikings. And so what these guys are finding up here on these mountains is the remains of my ancestors who were not chasing bison along their drive lines, they were chasing caribou and hunting them, and they're finding clothing that people left melting out of the ice, they're finding weapons, all kinds of stuff. This is another photo of the valley. My ancestors carved things in the rocks that look like hunting scenes at Dinwoody. Elk and deer and bears and people running around with spears poking them. Same kind of adaptation. How you live is in prehistoric times was determined by the environment you lived in, whether it's the Arctic of Norway in the high mountains or the high mountains of Wyoming and Dinwoody. Very similar. And this is where my Indian students start to get a little bit angry because they're looking at these pictures of my ancestors living up there in the mountains in the summertime in teepees in Norway, and in the winter living in earth lodges like this. And that's very similar to the adaptations. The Plains Indians, earth lodges in the winter all across the Dakotas, Nebraska, teepees in the summertime out here at South Pass. And they're asking me, why do all those white people believe that my ancestors could live in the mountains in the cold and nobody thinks Indians are smart enough or tough enough to do it? Even though we've got all this evidence pointing that they did. And so they're looking at these textbooks thinking those textbooks are racist. They're treating us like we're simple brown-skinned people, and they don't like that. So part of what I make my students do too is actually I have to put on a tie to come here, they have to put on a tie and go present papers at professional conferences that talk about their discoveries. Because part of what they need to know once they leave school is how do you disseminate your information, your discoveries to other people. So we travel, part of what we do in the spring is work on papers and then travel around and present their papers, their research at different conferences. Again, like that second slide said, our whole program is student focused. It's not there to make me, the famous old archaeologist. It's there to give them the skills to go out and do what needs to be done in spite of any difficulties that they have based on race or family background or first-generation college or economics or anything else. But we've been asked to submit abstracts to go present results of our findings on Dinwoody at the International Glacial Archaeology Symposium in Innsbruck, Austria next October. Most of these kids have never been out of Wyoming. Some of them have never been out of Fremont County. So part of what I'm going to be doing for the next few months is writing grant proposals to take a bunch of students from the reservation to Austria to try and find money for that. That's tough because everybody thinks we just want to go on vacation. My kids suffer no matter where they go, I will tell you that much. They have to perform or they don't get to go, whether we're going up onto the ice or Austria or Casper or Cheyenne or anywhere else. And that, okay, Maggie, I'm done. There.
Okay, so are there any questions?
What sort of evidence would you find that would indicate or prove that they would be able to winter over? You said you would be looking for evidence.
What I'm hoping to find is something similar to what Larry Todd from Colorado State found up in the Absarokas a couple of years ago, and that would be fetal mandibles from sheep or elk or deer. Because that means they were killed. That means that the cow or the doe was killed in the wintertime if you've got fetal mandibles buried in these sites. So we can get season, because we know, I mean, they have their babies in the spring, right? So if you get a fetal mandible with the teeth just starting to erupt, you can say this is December or January or February based on the development of those teeth. A problem with that is that the soil up here is really terrible. The soil chemistry and the moisture qualities is really terrible for preservation of organic material. But we're going to trust that our luck that somehow in between a couple boulders or something, we can find something like that, which would be the easiest. Other source of information will be a little harder to interpret. I like the path of least resistance. I want fetal mandibles.
If you've got significant populations of people living up high and you're spending a long period of time, it seems to me that one of the issues that they have to deal with is food storage and preservation and protection from the wolf population. Do you have any ideas about how they might have dealt with that?
At the Colby Mammoth site up near Warland, what we have there is an archaeological site where they actually, after they butchered the mammoth, several mammoths, they took all the bones and piled the bones up over the meat, and then it all froze together into a solid mass that bears or wolves wouldn't be able to get into. And then, there are other cases where, now you go up into the forest and the bear doesn't like you and the bear's not afraid of you and it eats you. But back in prehistoric times, these people had a sort of a love-hate relationship with bears and wolves, and I think bears probably were inclined typically to stay away from these little noisy predators with bows and arrows and spears and things like that. I have well, she's deceased now, but I had in graduate school a friend, a Crow Indian woman whose last name was Bad Bear because one of her great-great-great-grandparents had been in camp one day when a grizzly came down out of the bighorns. It was a bad bear. It started tearing the camp apart, and this guy went in and killed it with a bow and a knife, and so then the family name became Bad Bear. So, I mean, this issue of how do you preserve food that we deal with our students, because Brad said I can't go feed my students to the bears. I mean, that's also a prehistoric issue. But people back then were armed and they hunted constantly and they liked wearing those bear hats with the bear cape over the back, and I think bears probably tried to avoid people more than they do today. So that would be part, I mean, you've got the freezing to preserve that meat, and then just we're the apex hunter. We go everywhere and we kill anything that gets in our way. Whether it's because they go to the wrong church or have the wrong color of skin or they have bigger teeth than us or whatever. That's the human nature. Yes?
Glaciers all over the world shrinking at 2 meters a year.
I don't know the rate of other glaciers melting, but it's in most places. Now, there are some places like in Antarctica, some of the ice is actually accumulating down south. But in most parts of the world, whether it's especially in the northern hemisphere, they're disappearing rapidly, and they're melting farther away than they've ever done in the past. Whether we're talking the ultrathermal, which was a real hot, dry period in the northern hemisphere from about 8,000 years ago to 5,000 years ago, there was still more ice around than there is up here today. They're disappearing rapidly.
Brad just said like I think 8 out of like 4,000 glaciers they're monitoring are not shrink.
Yeah.
All the others are shrink.
He's got data, 8 out of 4,000 glaciers being monitored, only 8 are not shrinking. You're the expert.
Well, I just happen to.
He just makes stuff up too.
Thank you.
Yeah. Yes, sir.
Didn't Matt and Rebecca find dense fur up in some of the ice patches they were looking at 10,000 feet and thinking that there were periods of much warmer weather?
There have been, I mean, like the ice began melting 15, 20,000 years ago. The glaciers have been retreating a long time. There are some times, like during the Little Ice Age where I showed you that glacial moraine, where they actually grew. And so I mean, the climate fluctuates from year to year. Generally, the trend has been the planet's getting warmer, the glaciers are receding for thousands of years. The question is, like Matt Stern here from Jackson and other researchers are finding that there were times through thousands of years where tree line was much higher than it is today, indicating warmer climate periods that lasted centuries or thousands of years. I also took some of my students up with Craig Lee from INSTAR, the Institute of Atmospheric or Arctic and Alpine Research out of Boulder, out of CU, and we were up in the Beartooth last fall in Montana working an ice patch up there with him, and as the ice melts, that's another place where there's a whole forest of fir trees melting out, and those trees have been buried in that ice for 5,000 years. And what I think, and I'm not the climate expert, but what I think is going on is that during that altithermal period, about 5, 6, 7,000 years ago, the northern hemisphere was much warmer and tree line was much higher. And then after about 5,000 years ago, things cooled down a little bit again, and the snows fell, those trees died, and they've been buried, encased in that ice since that time, and they're all melting out up here and in Montana and Alberta and Norway and all over the world right now. So what we're seeing is fluctuation, and people, our ancestors, my ancestors in Norway, my students' ancestors here in the Wind River Basin, have been adapting to changing climate forever. That's what drove us out of Africa hundreds of thousands of years ago. But what we're dealing with now is the climate is changing so much faster, and it doesn't even matter anymore why. You know, the argument, is it human caused or not, is almost, in my mind, irrelevant. It's happening so fast, and I think we've already passed the tipping point. We could cut all of our fossil fuel consumption to zero today, and it will still take so long for the atmosphere and everything else to recover that, I mean, we're not going to see those glaciers start coming back. But I'm no climate expert, so don't take my word for it. But based on what I've studied, that's what I think is happening.
We're going to have more questions at lunch. So,
You know, last time I talked for the Humanities Council in Cheyenne, they did the same thing. They said I'd used up 2 people's time and they kicked me off the stage.
I'm not kicking you off the stage because we didn't let you on the stage in the first place, right? Well, let us once again thank Todd Guenther.